Welcome to another exciting educational video brought to you by Upvision Concept Academy. We'll be looking at physics, and the topic for discussion today is reflection of light waves. We know that light is a form of wave and is also a form of energy called luminous energy. This energy causes a sensation of vision, enabling us to see. So anytime you are seeing objects, actually the object is reflecting light rays or waves into your eyes to make you to see. There are different kinds of objects. You have that is as classified under their nature in terms of bringing out light. You have self-luminous objects, and you have non-luminous objects, So a luminous object is an object that can produce reflections, can generate and emit light rays by itself. So these are luminous objects. Examples of luminous objects is sun. The sun can radiate light. You have the stars, even fireflies, natural animals, fireflies can also radiate light. They are luminous objects. So non-luminous objects requires a reflection from another luminous object. For example, the moon. The sun shines on the moon. The moon is non-luminous. That means it cannot reflect its own, generate its own light. It only reflects when the sun's light is incident on it. So when the sun rays are incident on it, it now reflects it. So when you see the moon, you think that the moon is producing its light, but no, it is actually a non-luminous object. So transmission of light. Light is an electromagnetic wave. It can pass through a vacuum and through a material. So it's electromagnetic. It does not require material medium. It can travel through space, and it can also travel through a material medium. So two things. So if light shines on the body, part of the light transmits through the body, the rest is reflected. The amount of light passing through a body depends on the nature of the body. If a large percentage of light falling on a body pass through it, the body is said to be transparent. So if you have a body like this is a body. And let me just have it in ticking form. So light ray comes through here. By the way, we represent light rays by a straight line and a directional marker showing where it is going. So this is a light ray now. If it passes through like this, passes through this object is what? Transparent. That's why we describe some orange as transparent, because light passes through them. If the light on this object bounces back, the ray bounces back, then it is not transparent, it is opaque. That means the object does not allow light to pass through it. The one that allows light to pass through it is transparent. The one that does not allow light to pass through it is opaque. The one that allows some amount of light to pass through and limits other, that means the intensity of light will drop. Let's say, for instance, now the light ray hits this object now. Some parts will pass through and some parts will go out as reflection. This is a translucent object. Translucent. So we have three kinds of objects depending on how it allows light to come through it. The transparent one is the one that allows light to come through it. The translucent one is the one that allows some part of light to pass and some to go back, and the opaque is the one that will not allow light to go through it. Okay. Okay, so this is ray of light. So a ray of light is the direction where the light goes. It is indicated by the arrow, like I said previously, where the arrow is facing. So if we have different kinds of light rays or beams, light rays or beams. So if they are going parallel, you understand? You see that we call it parallel beam. So the light rays are going parallel to each other. So we have the convergent beam. The convergent beams are beams that, or light rays that will converge at a point. You see, this arrow is going and is converging at this point. So this is convergent beam. The divergent beam is the beam that will radiate out of a point. So the convergent beam, from the name convergent, it converges at a point, like let's say point A, and divergent, it radiates out of a point, point B, while the parallel beam will go, parallel to each other. So these are types of rays and beams. So there are two natural effects that results from rectilinear propagation of light. So you have the formation of images, formation of image, number one, and number two, shadow effect or formation of shadow. So two things happen when light are propagated rectilinearly. When you say rectilinear propagation of light, is light going on a straight line. So light can travel on a straight line. And there are experiments to show that light travels on a straight line. If, for instance, you have a ray box, a ray box is just a box that is made for us to experiment light. So the ray box is made in a way that inside the ray box is coated with a dark color, and you have a light source inside. Let's call this one the light source. Then you now put a small hole where the light can come out. So if this light source is lit, you understand, light ray will go out from this source. So this ray box is used in the lab many times to study the effects of the light rays and beams. It is from this ray box we know that light propagates linearly. It is from here we can see that light cannot change its course. A ray cannot change its course. It must go on a straight line. That is why we call it rectilinear propagation. Rectilinear. That means it goes on a straight line. So I'm saying here that two effects happens, natural effects happens when light travels in a straight line. One, formation of shadows, and image. Okay, so what natural effects? I said shadows, and the eclipse. So for natural effects, I can say shadows and eclipse. So these are natural effects. Okay, so so for shadow, naturally when you stand, you see a dark outline of yourself. Maybe you are standing and you are blocking, you are facing the light source. Okay, let me take this off. Okay, so when you are standing, let's say this is a light source, for instance. Let me put a ray box in, or just put a light source like this. This is a light source, and somebody is standing, and the light is propagated. The ray propagated directly on the object. You see that there's an image formed on the ground here, That's a shadow, understand, as a result of this light not going through this object. So the shadow is cast. So this is a natural effect. Also, eclipse is also another natural effect of the rectilinear propagation of light. So I can actually illustrate this by using our ray box again. Let me just put the ray box here. The ray box. Okay, yeah, so I have um, a demonstration of the effects of rays on a body to form the shadow, So if I have a ray box here giving me a small light source, So incident rays coming from here will just hit these objects top and bottom and form a shadow on this screen. This is the screen, and form a shadow on this screen. Now, this shadow from the small light source will form a thick dark outline. That is, the objects, the image formed on this screen will be all solid, thick, you understand? And we call this shadow effect Umbra, only Umbra. So the small light source will give us only Umbra effect, that is thick dark shadow outlining this object. This is the object, and this is the image. This is the object, and this is the image formed on the screen. Image formed on the screen. Now, for the case of a big light source, the light is incident on this. So there are two kinds of shadow effects. This one that is thick here is the umbra, and this other outline is the penumbra. Penumbra. Okay, what's the difference? The difference is that because it is a big light source, understand, there are the rays incident directly on the tips of the object will go ahead and form the umbra, the thick dark shadow. Now there's also another kind of shadow form outside it that is hazy. Understand? It is formed by the penumbra. It is formed and it forms the penumbra. If you watch very closely, you see that the ray from the tip of this light source hits this object, hits the object, and goes ahead to form this tip of the image here on the screen. This is the screen. The screen can be a board. It can be a board where you receive the image form. That's the screen. It doesn't have to be a glass. It could be a board where you can receive the image, or even a glass, but you can use a board. So this tip of the light ray grazes on this tip of the object and forms the corresponding image on the screen. Likewise, this other ray hits this object and forms on the tip, on this tip. Understand? Now, this other one here that goes like this, it's because light will always go on a straight line as long as there's no object to refract it. So as it's going like this, it hits this part and it's not refracted, it still continues. Understand? So it continues and forms an image here. But the image, because there's nothing here, what is projecting is not really a thick outline. You understand? The same thing, this ray like this comes, hits this tip and goes and forms, because it must go on a straight line. It's not refracting. It must go on a straight line. So it hits this tip. So this outline here formed by these two rays that strayed off, it didn't go through this object, that strayed off will now form the penumbra. So the knowledge of how these things happen is what can explain what we know as partial eclipse and lunar eclipse or full eclipse. The partial eclipse or full eclipse, it is when the sun and the moon are actually aligned in such a way that the moon is blocking the sun from reaching the earth, and eclipse is formed. So I'm going to be explaining the phenomenon of eclipse using what we have just studied now. Okay, so I wonder whether you've heard about eclipse or you have ever experienced eclipse. Eclipse is a natural phenomenon that happens um, that causes the Earth, some part of the Earth, to experience total blackout or darkness. You understand? All of a sudden during the middle of the day. So it happens, natural phenomenon that happens when the sun and the moon and the earth are aligned in such a way that the moon is in between the sun and the earth. You know, the sun is actually static. Then the moon and the earth goes round the sun in their orbits. So there is an orbit, there is a particular part, orbit is a part where the moon normally goes round and uh, sorry, the moon goes around the earth and the earth goes around the sun. Yes, so they all go round in the orbit. You understand? So, but a time will come when in their movement, the moon is actually in between the sun and the earth. And when that happens, what I explained using the large light source effect, because the moon is a large source of light. In fact, it's even bigger than the Earth. The moon is a large source of light. So that large source of light effect, where you have shadow, two kinds of shadow casts. You have the Umbra, this is the Umbra region, and the Penumbra region. Now, these are rays from the sun. This ray comes like this and grazes the top of the moon and forms here. This one grazes this part and forms here. While this one goes like this, hits the moon and hits the earth. This part, these two rays that hit the tip of the moon and go through to the earth will form a shadow on the earth abruptly during the day when sun is supposed to be shining. The moon just comes and is in between the sun and the earth. And this shadow part is the umbra. These people here on the surface of the earth will be experiencing total blackout because this place is black. This moon is covering the sun from entering, coming to the earth at this point. So all this region in the earth will experience total eclipse, and this is the umbra. But the penumbra is where you have partial eclipse. You'll be seeing part of the sun and the moon is covering some parts. So this part, all these people here is the penumbra region. Theirs will be partial eclipse. They will just see that the sun is covered like this. Sun is shining like this, then now covers like this. So all this part is dark. So they'll be seeing this part of the sun, in the middle of the day until the position aligns again. The alignment is sorted. The sun and the moon are no longer in alignment. So these are just the phenomena of rectilinear propagation of light. That's light traveling on a straight line, forming eclipse and forming shadow. So we'll look at the pinhole camera and we'll see how we can determine the magnification of images produced by a light. Okay, so we have the pinhole camera. So the pinhole camera makes use of the fact that light travels on a straight line. It consists of the light box. This is the light box. The light box, and there's a hole at one point of the light box, and there is a screen at the end. So the hole is what makes the light to go in. Let me call this place the pinhole. This is the pinhole. The pinhole. So it's like a small hole that looks that a pin can fit in. Understand? So if we have an object, this is an object here. An object is outside the box. Understand? And there is a screen here to receive the image of the object. So the image is received at the screen inside the box. So the light rays, like all objects emit light rays, and they all travel in a straight line. So the light rays, there are many rays, just not, we're using these two simple rays to just depict how they go. Because normally the thing looks like this. If this is an object like this, every particle of this object will be emitting rays like this. Because I don't want it to be very clumsy, you understand? And I will not want to draw all the light rays. So I just represent the two rays, maybe the one at the tip, the two tips. So that's why we're having these two rays like this. So the ray at the tip here, goes into this place and reproduces itself. Whatever it is here, it reproduces it here. You understand? This one too also goes in like this. So they are all trying to go into the hole. If they were going straight, maybe it would be a different case. But they are trying to go into the hole. So as they are going into the hole like this, this one now, this is the tail, will go and reproduce at this point because it's skewed here. It's skewed here. So at the head will come here and the tail will go up. So this ray from this object forms an image. Now the image that is formed inside the pinhole camera is inverted. Inverted means it's upside down. Inverted. It means it's upside down. Okay. So we can actually study this ray box and see how we can obtain what we call magnification. Magnification is just actually a change in size of the final image that is produced in the object, by the object, sorry. So magnification is just like a factor, it's a factor, number factor that determines how larger or smaller the final image is formed. Excuse me. So if I look at this thing like this, geometrically speaking, this actually, I can label this point A, point B, then here point C, point D. Then this place I label it E and F. You can see that geometrically, there's a triangle that is formed here. AE, let me call this O. AEO is a triangle. This is a triangle. And OFC, they are triangles and are similar triangles. So if we apply similar triangle rule, you can see that EA over EO is the same thing as EA over EO, the same thing as CF over OF. This is similar triangle rule. And what is EO? By extension, I can say AEB, this B, AEB is equals to 2EA. Also, CFD is equals to 2CF. That means this CF and FD, they are the same. That's if I add the two of them, they are equal. So I can add the two of them to form the whole. So what I'm trying to do here now is I'm trying to bring out the relationship to show magnification. If by similar triangle, I say this and this is similar to this and this, and this and this is similar to this and this, it therefore means that AE is object height. Object height is like object height. You understand? It's like object height. Or I can even go further. So I'm going that route. I can still say here, similar triangle rule again. A B over EO, AB over EO is equals to CD over OF. What is AB? AB is what? The object height. And EO is the object distance. Object distance. Look at that. I'm introducing some terms now. AB, object height of the object. Then EO is the object distance between this object and where the pinhole starts. Okay, so it's equals to, then CD is the what? Image height. CD is the image height. The image is formed. And OF is the object image distance. So you can see that the relationship between image distance, object distance, and image height, object height. So relationship is what we know is what we call magnification. Magnification is just the ratio of the image to the object. So I can come here and say M magnification is equals to image distance slash height or height over object distance slash height. So that's when this one goes up like this and this one comes down, you have that ratio correct. So that is magnification. So we're going to be applying that in some questions, and we'll see how it goes. Okay, so we have a question on the board here. It says the height of an object placed at a center, at a distance of 60 cm from the hole of a pinhole camera is 15 cm. If the length of the camera is 10 cm, calculate the magnification produced by the camera and the height of the image. So first off, I would like to use pictures to depict what we have on the board there. So this is the pinhole. It said the height of an object. So the object height is object. Object height is what? Is 15 cm. That's object height. But they said the height of the object placed at 60 cm from the pinhole. So this object is placed, the distance between here and here is 60 cm. Okay. If the length of the camera, so the camera length is 10 cm. So mind you, camera length is the distance of the image. You understand? The image is also always formed at the edge of the camera. You understand? And the one before the camera, distance before the camera is the object distance. Why this is the object height? So magnification is either of these two ratios. Ratio of object height, I normally use V as object height, I will explain later. Then V as image height, then U as object height. So a ratio of image height to object height, or image distance to object distance. So I've explained it to V is the image, while U is the object. V is the image. So you're either comparing the image height to the object height, or the image distance to the object distance. Now we are given the objects. We have two things here. We have this and this. These are distances. We have this distance and this distance. So we have these two parameters. I can get magnification. Magnification straight away is image distance. Image distance is 10 over object distance is 60. Why? Because 10 is the distance between the pinhole and where the image is formed. So that's where the image distance is. Understand? Why the object distance is where the object starts from to where the camera starts from. Okay, so this one is the ratio of 1 to 6. So magnification is equals to 0.16. Magnification, I say it's a constant. It's a constant. Okay, so that's magnification. But for the next one, they say we should find the image height. But we have the object height. So again, this same thing applies to this one, to this side. So magnification is still the same thing as comparing the image height over object height. I'm spelling object already. Object height. Always define your parameters. So I've defined it and say where V is what? The image, then height. And U is the object height. So I've already got the magnification as 0.16. 0.16. Is it not? 0.167. 7. That's by approximation. And I'm looking for what? I'm looking for the height of the image. So VH is still unknown, but UH is given as 15. So I put 15 down here. So VH is equals to 0.167 times 15. Final answer is 2.5 cm. So the image height is 2.5 cm. So we'll stop here for today. Kindly subscribe to our channel. I hope this has been informative for you. I'd like to thank you for viewing.